Okay, good morning. Uh, we continue the treatment of chemistry questions. So, from the questions I have here, the first question goes: the shape of the s orbital is elliptical, B spiral, C circular, D spherical. So, the s orbital. So, the answer to the question is spherical. So, the s orbital is spherical, and so these orbitals, when we say an orbital, or I mean, an orbital is a region in an atom where the an electron is probably found, can be found, or can be located. So we call it an orbital. And we have four of such orbitals: the s, p, d, and f orbitals. So in an s orbital, we can have a maximum of two electrons. In a p orbital, we can have a maximum of six electrons. In a d orbital, we can have a maximum of 10. Then in an f orbital, we can have a maximum of 14 electrons. And then there is what we call a degenerate orbitals. So in terms of that, s orbital does not have degenerate orbital. This has three degenerate orbitals. Then this has five, this has seven. So the number of degenerate orbitals is half of the maximum number of electrons that you can find in that orbital. So, and degenerate orbitals, each degenerate orbital can carry a maximum of two electrons. So, which means a ps orbital, this degenerates into ps, py, pz. So each of which will carry a maximum of two electrons. So, like I said, the shape of an s orbital is a spherical shape. So, in this is how it is. It's a spherical shape. An s orbital is a spherical shape. So, a p orbital and a spiral. So, like I said, we have three of it. Of three orbitals. So one is oriented in the s-axis, you understand? Like the one is oriented in the x-axis. Let's say this is the y-axis. Then this is your by. Then the other one is oriented. That is, this should be the ps. Then your pz is, you know, in that direction. So this is your pz. So the same thing applies to the other, the d and f orbitals. So the shape of an s orbital is spherical. Then another thing we need to talk about under this orbital, actually, I can tell you, no more than 30 minutes video here on this very class, only to find out that it was not recording. So I got to kind of rush it. So the next thing to talk about here is this, that we need to know, will be very important for us for our jam is what do I call it? Writing electronic configuration using the SPDF format. So, like, if I to write electronic configuration of magnesium, so we know something like this: arranging the electrons in terms of the energy level, the first energy level, the K shell, the K L shell, the M shell, and so on. It can also be written as 1s2, 2s2, 2p6, 3s2. So using the SPDF form. So, and the electrons are the indices, that is the exponents, the power of each of the orbital gives you the electrons. So total, in this case, 2 plus 2 plus 6 plus 2 is 12. So the number you have here before the letters indicates the energy level of the orbital. So this is to say that this s orbital is for energy level 1. This is the s orbital of energy level 2. So and our energy levels, we know they are 1, 2, 3, 4, 5, 6, 7. So, and in writing electronic configuration using this SPDF method, the orbitals we are arranged in order of their increasing energy or increasing energy level. So this is to say that 2s has a higher is at higher energy level than 1s, and so on and so forth. If this is an aluminium with 13 electrons, we would have had the next would have been 3p1. But this is a magnesium, so there's no need going to that. So then the next thing we'll do is to give you the format. But if you have a very large atom, like if you have calcium, for instance, with 20, it would have been what 2882. So which we arrange as 1s2, 2p2, 2p6. We are done with this. Then 3s2, 3p6. We are done with this. Then 4s2. So you can see. So if you have larger than calcium, like an atom with 25, or the name of that atom, from a periodic you can get that element with 25. So that would have been 1s2, 2, sorry, this is 2s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is 20. Then we're still left with 5. I mean, and this 5. So what do we do now? We would expect that the next should be what 4p, if 4p what, maybe the remaining 5 should go to 4p, but it will not be so. Before 4p will bring 3d and give it the whole of the 5. So you can see a difference here. So you would have like, well, it should be 4p 5. So but it doesn't go that way. So because 4p has a higher energy level than 3d, so 3d has to come before 4p. So how then do you know the proper arrangement? Then that will take us to the next thing we're going to talk about. So, like we said, we have the first energy level with only one S possible. Then the second energy level has these two possible. Then the third has these three possible. The fourth, 4S, 4P, 4D, and 4F. Then the fifth, 5S, 5P, 5D, 5F. Then 6S, 6P, 6D, 6F. Then 7S, 7P, 7D, 7F. So look at it. Draw diagonal line across. Don't make a mistake. So if it is properly drawn, you should have 10 of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we now write them diagonally starting from the first. So which means the very first orbital we should have is is what? A 1s, then followed by a 2s, then the next 2p. You'll be counting like this. So the 2s next is 3s, then 3p, 4s, 3d, 4p, 5s, 4d, 5p, and so on and so forth. The next will be 6s. 6s, then come come here 4F, 5D, 6P, 7S, then 5F, 6D, 7P, 6D, 7P, then 6F, 7D, 6F, 7D, then finally 7F. So this is the arrangement. So if you follow these arrangements for the that element to 25, so this is how it goes to have 3D before 4P. So if you can remember this, or if you can actually get this one from here. You write this from 1 to 7. So the first energy level has only 1s, the second 2s and 2p, and the third 3s, 3p, 3d. Then the rest, you can have the SPDF completed. Then you now draw a diagonal line through them, and then start writing counter from top to bottom, top to bottom. You understand like that? So this will assist you in knowing the correct format of writing the chain configuration using SPDF. So that is that. Maybe later, if you come across a question relating to this, then we can say more on that. But I believe maybe with this, you should be able to answer some question, any question coming from that aspect. As far as that is concerned, we really need to cover much as the JAMB exam is fast approaching. So the next question is the property of chlorine, which cause hydrogen chloride to be more ionic than the chlorine molecule is HCl and chlorine. So according to the question, this is more ionic than this. And why? It is due to a certain property of chlorine that makes hydrogen chloride gas to be more ionic than chlorine gas. So let's see. And sorry. Okay. So let's see why this is from the options they gave: electronegativity, electropositivity, electron affinity, electrovalency. So is it electronegativity? Let's see. Is it electropositivity? So when you say electronegativity, it is the tendency of an atom to attract a shared electron in a covalent molecule to itself. When an atom in a covalent combination has the higher tendency of attracting the electron towards itself, then you say it's more electronegative than its counterpart. So then you have electropositivity, the ease with which an atom can lose an electron. So it's electropositivity, and this one is a property of the metals. And we can't have any metals here. Chlorine is not a metal, so we should not talk about electropositivity. Then another option there says electron affinity is about the energy released in the formation of a negatively charged ion. You understand? So, and you have electrovalency, which is a bonding involving transfer of electron between two elements or two atoms. So then electronegativity is the answer. That is the answer. Well, let us explain it. So how is it responsible for this being more ionic than this? So what do you mean by a compound being ionic in the first place? When you say a compound is ionic, especially a binary compound like this, it means the two constituents, radicals uh, carry opposite signs. They carry charges. Opposite charges. So which means if this is ionic, for instance, it means this carries some positive charge, then this carries some negative charge. because a compound is either ionic or non-ionic. So a non-ionic compound is non-polar. So there doesn't there is nothing like a charge between the the constituent elements. But if it is ionic, it means it is actually a combination of charge, two oppositely charged atoms. So what makes chlorine, this compound, the that property of chlorine that makes this more ionic than this? So we say it's electronegativity. That's the answer. But we need to explain why it is so. But if it's electronegativity, then we have the chlorine here. We also have the same chlorine here. Why is it responsible for the higher positive ionic property of this than it is here? So, like I said, in this very molecule HCl, we know the molecule, the hydrogen chloride is formed by covalence. So by covalence, it means this molecule is formed by electron share. So the two participating atoms share the electron. Like hydrogen has a lone electron, then chlorine being 287, we are considering only the outer shell. So it has 7. So chlorine requires one more to attain the octet configuration. An octet configuration is a stable configuration. So it wants to be such that it does not even need more electron here. It wants to attain a stable, a completely filled shell as the outer shell. So why in the case of hydrogen, this is chlorine. In the case of hydrogen, hydrogen wants to be duplet, attain duplet, the duplet structure, where it's first and the only and the last shell. It is the first and also the last shell, which can contain a maximum of 2. It wants to attain that maximum. You understand? That's the same what we call duplet electronic structure. So what does it do? It requires one to achieve that. This also requires one to achieve its own. So and the two of them have to combine. So what did they do? If this transfers this to this, yes, this will attain, but this is left with no electron. It just becomes an ordinary proton. So, but this is to happen by covalency. So instead, they have to share, and because of sharing, each brings its electron, and they share it instead of transferring. They share it so that you can count 2 for hydrogen and you can count 8 for chlorine. So this results in the formation of HCl. So you can see hydrogen single bonds chlorine. So the single bond represents this stroke, this single bond represents a shared pair, this shared pair of electron. So now, what now makes it normally a covalent molecule or a compound that is formed by covalency should be non-polar, should be non-ionic. It shouldn't the component should not carry any charge. So, but if the electronegativity of the two atoms is wide, the electronegativity difference, if it is very wide, then they are going to tend to be ionic, even if it is partially ionic. Understand? So, if you look at the location of hydrogen in the periodic table, in the group 1, then as of chlorine in the group 7, they are far apart. And electronegativity is a property of the non-metal. The non-metals are more electronegative than the metals. Though hydrogen is a non-metal, but located in the group 1, where you have the alkali metals. So, and by the value of hydrogen, electronegativity value of hydrogen, being at that value, at that side is very low compared to chlorine. So the electronegativity increases as we move across the periodic table from left to right. As we move away from metals to non-metals, it increases in that direction. So which means chlorine is going to have, even if you can't tell the value, it's going to have a very higher value, being in the group 7 and group 1. So the group 1 elements, the group 1 elements have the least of electronegativity, then we expect the highest with the group 7. So you can see the difference. So that means the electronegativity difference will be very wide. And if it is wide, what does it imply? Chlorine has higher electronegativity. It means this shared electron is supposed to be for the two of them, and it is actually supposed to be located in such a way that it is not closer to any of them than the second. That is, but that is not usually the case because the two elements have different electronegativity, and the difference is because the difference is very large, then the electron will reside more with the chlorine. So because the chlorine has larger electron attracting power than hydrogen, so the shared electron will be attracted more closer to chlorine than hydrogen. So that will not create uh, partial charges on each of them. Because when electron is removed from an atom, it leaves a positive ion. It makes the atom positively charged. Then when an electron is added to an atom, it makes it negatively charged. So when chlorine attracts the electron to itself, it gives it a partial negative charge. When it is subtracted, taken away from hydrogen, it leaves it with a partial positive charge. And when you have two positively charged particles, then they get bonded to form what we call ionic molecule. So the case is not the same with chlorine because how is chlorine molecule formed? Chlorine molecule is also formed by covalency between two chlorine atoms. So because they have the same electronegativity because it's the same element that is involved. So they are also going to share electron just like we have here. This one brings its own one electron, this one brings the share and become and form the chlorine molecule. So, but in this case, the electron will reside in between. So because they have equal electronegativity, the electronegativity difference is zero. So no electron is not shifted towards or closer to any of them. So it maintains neutrality and there's no formation of partial polarity that would have led to Cl2 being ionic. I think this is explained properly. So that answers that question. Then the third question here, okay, we actually jumped to a question that says which of the following mixture of gases is likely to burn in flame? Helium and neon, neon and nitrogen, neon and hydrogen, nitrogen and helium. So if you look at some of the mentioned elements there, like helium, neon, they are inert gases. So in a good day, they should be non-reactive. So if you now have a mixture of helium and neon, for them to burn in a flame is highly unlikely. Then with neon and nitrogen, with the presence of nitrogen, like you know, will not support much of that burning in the flame because of the weight of hydrogen in relation to the oxygen. So neon and hydrogen will do better, and that is the answer: neon and hydrogen. The nitrogen and helium is just like combining neon and nitrogen. It's like combining two inactive passive elements. They are not combustible, so together, so they are burning in it will be very hard. So we know hydrogen to be to burn hydrogen burns well in a flame. So its combination with neon will burn better. So the answer is neon and hydrogen. Then the next question says, in the experiment above, S is a mixture of nitrogen, carbon fluoride, and so in that very question here, the mentioned experiment above, but the experiment is not really here. So we're jumping that question. The experiment is not given. Then we now move to the fourth question, or rather, the fourth, I think. Okay, or the fifth question here. So which says, it says that what? A given volume of methane, hmm? This is methane, CH4. A given volume of methane diffuses in 20 seconds. A given volume diffuses in 20 seconds. Then how long will it take same volume of sulfur, okay, sulfur 6 oxide, same volume of sulfur 6 oxide to diffuse under the same condition? So this one will diffuse in how many seconds? Eh? So in how many seconds? So that is the time it will take if maintain diffuses in 20 seconds, then how long will it take the same volume of sulfur 6 oxide to also diffuse? You can take the question again. A given volume of methane diffuses in 20 seconds. How long will it take the same volume uh, of sulfur 6 oxide to diffuse under the same condition? So this is question can be treated using the using Graham's law of diffusion. So if you remember your gas laws, there's Graham's law of diffusion. So this law is actually saying that the rate of diffusion of a given volume of a gas is inversely proportional to the square root of its density. What is it saying? That the rate of diffusion uh, of a gas, rate of diffusion of a gas is inversely proportional to what? The square root of the density of the gas. So what is this? Is this saying? The rate of diffusion means it's a measure of how fast a gas will diffuse. And we all understand what diffusion means. Diffusion is just a movement of a molecule from a region of higher concentrations to a region of lower concentration. Example is if in this room I open a bottle of a perfume here and let out some of the perfume at this point. I spray the perfume at this point. Then after a time, the this fragrance will be perceived at the other edge. So what has happened? It is by diffusion. So the molecules of the perfume have diffused maybe through the air. Air is the medium, medium. So diffuses through the air and gets spread everywhere. So this is diffusion. So how fast will this diffusion happen? Will this movement happen from one end to another? Depends on many factors, many properties of the gas, and one of that property is the density. So by saying the rate of diffusion is inversely proportional to density means the higher the density of a gas, then the short, the what do I call it? The lower the rate of diffusion. I think that is understood, which means having a density under. So if it grows bigger, then 1 divided by the density gives us a lower value. So which means the rate of diffusion will be low with a very high density. So if the gas is very highly dense, so this is to say that the quantity of heat that will actually diffuse by unit time will be less than when it is a less dense gas. This is what the law is trying to say. So this law we can write, if we represent the rate as R, then we say 1 over this density, maybe we use it to represent it. So if I'm now comparing two gases of the same volume, or even before that, in place of density, we can use mass. And we know that density, though we represent density with D here, density is mass all over volume. So which means we can decide to write in place of density, we can decide to write mass because density is directly proportional to mass. So that is to say that this as well can be written as in terms of mass. Understand? So and then what if we have to then that mass also we know a mass is also directly proportional. For instance, we have mole equals to mass over molar mass, then which means mass is equals to mole multiplied by molar mass. So mass is also directly proportional to the molar mass. That's why we actually use the molar mass of the substance in place of the mass, whichever way. Then how do we now bring in time? So if I have to bring in time, then so we are going to say that time T1 in comparing two gases. So T1 over T2 then should be equals to M1 over M2. I don't know. It is correct. Let's check. Let's check. Like we just mentioned that rate rate is inversely proportional to mass, whether molar mass or normal mass. So rate usually is the number of molecules involved all over time. So directly proportional to mass. Then, but when it comes to comparing for two gases, okay, if you remove this side of proportionality and replace it with equality, then we can call this a constant. Understand? So we can call this a constant, which means this constant is actually n over t root n. So we can have this as a constant. So this is to say that if you are comparing two gases with of the same volume, so if they are of the same volume, then the gas one will have to be N1. Then the time it takes gas one to diffuse will be T1. Then the molar mass of gas one should be N1. This is a constant, and it will be the same for the same constant for the other gas of the same volume. So that means we can actually equate the two because the same constant is obtained. So we can say M2 for the other gas, for gas 2, T2, and M2. So if this is the case, then N1 is N2 because we are considering equal volume of the gases. So the number of mole, we believe is the same thing. So if that is the case, this cancels out, this can cancel out. And if it cancels out, we are like having M1 over T1, then M2 over T2. So I want to combine the T in one side and then the M in the other side. So how do I do that? So I can do that by saying this over this is equals to this over this. Understand? Or gradually, if I multiply this by this, I multiply both sides by T2 and divide both sides by M1. So that if I do that, I'll have T2 over T1 equals M2 over M1. Understand? So this is the same thing as T1 over T2 and M1 over M2. So, okay, so this is the relationship between time and the molar mass for two gases. So this is to say that in the case of time, if you are using time, it is like a direct proportionality that we're going to encounter. It's like a direct proportionality. So if there is the case, how do we go about it? Then, so this is the formula we're actually going to use to answer our question. So for the first gas, let's assume our methane is gas 1, then sulfur oxide is gas 2. And in the question, they gave the atomic masses. Carbon is 12, hydrogen is 1, sulfur is 32, oxygen is 16. So, but before, so we are also given the time. So in this case, methane, we tag methane as 1. So which means time T1 will be what? 20. Hmm? T1 is given as 20 seconds. So T2 is what we are finding for sulfur 6 oxide. Then what is M1? That is, this M1, take note, is the molar mass of methane. So which will be 12 plus 1 times 4. So I think that will give us 16. Then M2 is the molar mass of sulfur 6 oxide. So which we give sulfur is 32, oxygen is 16, then multiplied by 3. So this will give us what will that give us? I think this one is 32 plus 48. So this should give 8, I think. Yeah. 8 plus 32 is 40, plus 48. So to give us that. If I'm not mistaken, then that is the, yeah, it is 80. So if this is the case, then we can come back here to substitute. So T1, like I said, is 20, T2 unknown, M1 16, M2 80 using this formula. So if this is the case, if this is the case, then okay. So if this is the case, then we should have T2 equals 20, 80 all over 16. So this we can say this is 20. We'll put everything here. 8 times 16 is 20 times 4 here is 20. 4 here is 4. Yeah, so 4 is 16 is 4. Okay. Then we can go straight to say 8 here is 10. And 8 here is 2. Which means this will still go to 25 all over 1, or just 20 root 5. So T2 will be equals to 20 root 5. So what is square root of 5? Let's see. Calculator here. Okay. Square root of 5. Square root of 5. 2.236. So square root of 5 gives me 2.236. 2.236. So okay, 2.236 multiplied by 20, it gives me 44.72. So that is supposed to be the answer. You understand? If they actually did it correctly on their side. But if you look at the option, you have 40, 60, 25 seconds. So that is to say that maybe like okay, let's take SO3. Sulfur is 32, oxygen is 16. I think 16 times 3 is 48. 48 plus 32 is 80. Okay, so but I suspected they are they actually gives SO2 rather than sulfur 6 oxide, sulfur 2 oxide. So if it was sulfur 2 oxide, at this very point, it is sulfur 2 sulfur for 4 oxide, that is SO2. SO2 that would have given like 32 plus 16 times 232, which is 64. So that would have given us 64 here. And if this is 64, we would have gotten 20 root of 64 over 16. So which will be 20 times root of 64 is 8, of 16 is 4. So that would have given us like 40 seconds. So it would have given us 40 seconds as the answer. That is if this is SO2, that is of a fluoride rather than SO3. Or if it were SO3, that's the answer. So the answer is, what do I call it? 44.72. But we don't have it here. But I suspect it is SO2. Maybe the mistake came from when we were lifting the question from the jam question. So I don't think this very one is direct from the jam question. Maybe it was reprinted or typed and printed. So because from all the options we have 40 seconds, 60 seconds. So supposing it were so for that. So with a mass of 64 and then we take with a mass of 16. So we can see that um, the rate of diffusion is twice. So it takes a longer time for it to diffuse, having a higher mass. That is what it infers. If it takes 20 seconds, within 20 seconds to diffuse, it is less dense. It will take a higher time for this to diffuse because it is denser. So that is what you need to know. That formula, the formula you need to have to come into term with is if the density, if it is time, if it is in terms of time and mass, and molar mass, then it is T1 over T2 equals M1 over M2. So if it is in terms of density, you understand, it is the same thing. Then if it is in terms of rate, to be R1 over R2 is equals to D1 all over D2. So you have to take note of this. Because most questions uses time and the molar mass. So all you do is to substitute what you are given and then to find what is unknown. Okay.